de Paris. Donc, hier, on aura 3 présentations. On vous remercie pour être ici et surtout, on remercie Christian Perrenoud qui va commencer aujourd'hui et Anne-Marie Moigne qui va suivre après et David Clordeau qui sera dans l'après-midi. Donc, on peut commencer. On vous rappelle qu'à la fin, vous aurez la possibilité de faire vos questions. Merci, Christian. À toi.
Ah ben, avec plaisir, merci à vous. Désolé des petits problèmes qui me sont inhérents. The talk, the aim of the talk is to present the stratigraphy and the geoarchaeological studies of the Caune de l'Arago site. So there will be a short presentation of its location, of the history of the excavations and the research, and then there will be a little catalogue of what has been applied, which methods have been applied to study this site and to try to understand its signification. So the site, voilà, merci. The site is located in the south of France, that is in the northwest of the Mediterranean basin. And it's located between the sea. Nowadays, the shoreline is 24 kilometers from the site, and close to the Pyrenees also, which is the mountain that separates the France and Spain and Iberia. And so this position is so between two domains, the mountainous and the plain. You can see on the main image that the continental shelf is quite big in front of the shoreline nowadays. So there's a big, the landscape is quite wide, but it depends on the climatic conditions. That is, when it's really cold, of course, there will be a continental shelf accessible to animals and humans. But during interglacials, it is like the nowadays shoreline. So the Pyrenees Mountain are close. The next slide, please. The Pyrenees Mountain are as high as 3,000 meters, and it's the slide shows the Arago cave. It's from Arago cave. You can see the valley of Tautavel and Vingros, which is 5 kilometers long and 1 kilometer wide, roughly. In the back at the back of the photo, you can see the Canigou mountain, so the first big mountain of the Pyrenees. That is 2,800 meters. So the cave on the right, the entrance of the cave is dominating this this quite closed valley. It's a limestone cave dug in the Cretaceous limestones. So you can see the cave is close to the gorges. On the left, there is the Goulerous Gorge, where the river Verdouble flows, and the cave is at the bottom of the cliff on the right side of the photographs. That is on the left side of the river. And so the next also. The cave is located. The entrance is on the circle, on the upper right part of the photo, and it's nowadays 80 meters above the little river that is flowing just beside it. So the next, please. The cave has been revealed first by Farine, and it has been it's a naturalist, and he was brought in the cave by somebody, we don't know exactly who, but he discovered the bones, the mammalian fauna of the Caune de l'Arago. At that time, it was called Cova d'Argou. And he studied the bones, but didn't manage to understand and to determine some species. And so you can have the next one, please. And so he asked Marcel de Serres, who was already a famous geologist at the Montpellier University, that is 150 kilometers from there. And with Marcel de Serres, they both published the first scientific note on Cova d'Argou, on their research. And it has been published in 1829. That is the next slide, presenting the publication in the Sciences Naturelles. And there has been also a public presentation in the Academy of Sciences in Paris. And so the conclusions were it's an antediluvian fauna, but they didn't recognize any archaeological impact, any human impact on the infilling. And then almost 50 years later, Félix Regnault, in 1876, wanted to make more research in Arago Cave. He said that it deserves more research, but it stayed, in fact, untouched until 1948. This is the next slide. It's a great thing that the cave didn't suffer quite quick excavations during the 19th century. And so in 1948, Jean Abel-Anet on the photo has gone in the cave with his cousin, Georges Tôle, and he revealed the archaeological dimension of the cave, because he found some flints, as you can see, some hornfels, and he revealed also a little Neolithic occupation with one fragment of pottery. These are the 5 first objects that we know from Cova d'Argou, still Grotte d'Argou at that time, but it turns quickly into Caune de l'Arago. That means Arago Cave. And so the rediscovery of Jean Abel-Anet in 1948, in fact, next please, in fact opened the site to many different people in the vicinity or a bit further, even from Carcassonne. So these are the different. This is the map of the cave that is 30 meters long, 10 meters wide, roughly, and the different colors represent the different excavations, quite quick excavations made by these amateurs, in a way, between 1948 and 1963. So the site began to suffer at that time from these not well-planned excavations. And next, please. In 1963, Jean Abel-Anet, which is in the middle of the photograph, brought Henri and Marie-Antoinette de Lumley in the site, and Henri de Lumley decided to proceed to rescue excavations from the year after. So the first work has been made in the cave in 1964 with methodic excavations. And in 1965, it has been ranked as a cultural heritage site, most of all at that time, to protect it from quite quick excavations. And so these were kind of rescue excavations in 1964. And in 1965 and 1966, they prepared, Mr. Delumle's team prepared the site to extensive excavations. And so this is the next slide. In 1967 are the first positioned objects in the cave, with so the classic grid, 1 square meter grid, and this is the illustration of the squares that have been excavated in 1967, the first campaign of programmed excavations. It has been under the direction of Henri Delumle from 67 to 77 for the excavations. And the next is from 78 to 97. The next slide, please. So, yeah, Mr. Delumle, during Mr. Delumle's direction, in a way, even if he's still directing and coordinating all the studies, and it's a big team to try to understand the site. And so in 1971, there was the big discovery. You can see Mr. Delumle on the right, totally on the left, Jean Pifteau, which is a famous paleontologist, and with the skull, the Arago 21 face that has been excavated, that has been found in 1971, and with the human mandible, Arago 13, found 2 years before. And so the next slide is just to say that Marie-Antoinette Delumle was the head of the excavation between 78 and 97. And it's the next slide is Anne-Marie Moine, which will present the next communication on Arago, has been the chief of excavation from 98 to 2006. And she's still, of course, directing the study of the faunal remains. So Mr. Delumle is more prehistorian, then it was more paleoanthropologist, Marie-Antoinette Delumle, then Anne-Marie Moine as paleontologist and archaeozoologist that directed the site. And from 2007 until 2018, it was me with more a geological specialty who was heading the excavations. At that time, so 11 meters of the site have been excavated. That is 2/3 of the total infilling that we will see just afterwards. And that represents more than 400,000 objects well positioned into the cave between these walls. So I will not speak a lot about the objects because it's the aim of the next talk. I will more present what has been done to understand the cave, and to understand the infilling, how did it form, and so the site formation processes. So what we know is that in gray there is the cave with a little roof now in the front on the right part of the site to protect it from the direct sun. And there is a little also a little bit more west. There is a little bit haven that is on the plateau. You can access to it from the plateau. but then to understand if both cavities are representing the same one at some time, some geophysical survey has been made. Some research has been made in the cave to know the thickness of the infilling, and some work has been done, of course, outside on the plateau. And so this is the next slide, presenting the main 4 different methods that have been used. Some corings have been made in the cave. The deepest coring has revealed 14 meters of sedimentation on where it has been cored. And everything of the sediments, of course, have been dug out, have been preserved and studied through palynological analysis, through geochronology, and of course through for sedimentological purposes. Some methods have been applied in the cave, which are seismic refraction and radar with different wavelength. And on the plateau, radar and electric resistivity have been used in order to know if Caune de l'Arago continues to the west and to the little haven that is on the cliff. And the result are presented on the next slides, on the next 2 slides. The first one is just to see that the Arago cave is continuing westwards, but with the results of the geophysical survey, no direct connection has been evidenced, but it probably is. It's just a location, a question of positioning the geophysical survey. So Caune de l'Arago, the end of Caune de l'Arago nowadays is not the end of the cavity. It continues westwards, and another main information obtained with this geophysical survey on the plateau on the outside is that there is another. It seems that there is another even bigger cavity, a bit more to the north, that is completely full of sediments. Nothing has been done to this in this infilling so far. In the cave, with the corings and with radar and this seismic refraction, it has been evidenced that 7 meters, more or less, 6 to 8 meters, are still to be excavated in the front part of the cave, which is the aim of the programmed excavations, in order to reach the oldest layers in the cave. So 11 meters, what you can see on the right is on the left are the 11 meters excavated. And so these are still the representation of, in color, of what is planned to be excavated in the next decades. So the next slide is presenting the evidence of the change in the geometry of the cave. The photo on the left shows Speleothems, stalagmites, that are nowadays in the sun. The photo in the middle shows the stalagmites on the lower left part of the cave, and at the back of the cave, also in the middle of the cave, in fact, where the sun is now making a little halo in the middle part of the cave in the photo. There are also thick speleothems that have been preserved. And this is an evidence of that the cave was much more closed than what we see now. and with different datings of this calcite, of these Speleothems, and with the geometry of the layers, we suppose that the opening of the cave occurred something like between 35 and 10,000 years ago. So most of the old Middle Pleistocene human occupations took place in a much darker cave. So the next slide is to present roughly what is known of the caves. That is the middle part of the drawing. And we can propose the reconstruction on the right of the drawing of an entrance gallery that was present, but that disappeared between 35 and 10,000 years ago. And on the left, what is in gray represents the hidden cavity where only the radar and seismic waves can penetrate nowadays. So the next slide is just to show what has been excavated so far of this quite big cavity that has been truncated in the east, and that is completely not accessible on the west part of the initial network. And the cave is now so a third of what was the original. Thank you. So next slide is to go a bit deeper in the stratigraphy of the site. It has been seen from the beginning during the excavation that the levels didn't seem to have stayed horizontal. The levels are wavy, they are bending, and so it has been decided from the beginning to excavate the site with the obligation of drawing all the profiles every meter. And so in order to have all the profiles every meter, to understand more the deformation of the sediments, it has been decided from the beginning to excavate 1 square out of 2. That is, if the grid of the cave represents a chessboard, we excavate first the white dots and then draw the profiles, the stratigraphic profiles, and then we extend and we excavate the black dots. And so that with this method, we can have the information of the stratigraphy, and then when we arrive on an archaeological layer, on a human occupation or animal occupation layer, we excavate in extension to have the spatial analysis and distribution of the objects of the surface of the level. So we have to gather all these informations square after square, square meter after square meter. It's not absolutely not, even if it's kind of a little alluvial basin, sedimentary basin more precisely. We cannot make only one profile, one dug, and to interpret more precisely the human occupation layers, it is important to do so, to do like we propose. And so we have a kind of a scale of excavation units during the excavations. Then we have the sedimentary units. We have, of course, the human occupations or animal occupations. We can define after studying the objects and their distribution, we can define the archaeostratigraphic units. The sedimentation has been regrouped in ensembles. We call the main over the meter of sediment that is quite homogeneously lain. are called ensembles, and then some complexes, even the higher level, is complex, stratigraphic complexes. So we can, with the stratigraphic reading and drawing and description, we define the stratigraphy of the cave. The next slide, please. So we can see here the three main complexes, which are the lower, the middle, and the upper complexes. Their size is due to their homogeneity. For example, the upper complex is mostly composed of speleothems with sands or silty sands interbedded, which is named Ensemble 4. Most of the upper complex is composed of the Ensemble 4, Stratigraphic Ensemble 4. A bit lower is the middle stratigraphic complex, which represents most of the sediments that have been excavated. That is almost 10 meters of thickness that have been excavated. And it has been subdivided in three ensembles. The upper and the lower are composed of laminated sands, which are so ensemble 1 and ensemble 3. And the middle ensemble, stratigraphic ensemble of the middle stratigraphic complex, is called ensemble 2. And it's more massive. It's non-laminated sediments in the field, and it seems much thinner sediments. So we'll see later how we interpret that. And the lowest stratigraphic complex is only known so far almost by the corings that have been made, and of course the radar and the other geological, geophysical methods. Thank you. Next, please. Next slide, please. So during the observation of the stratigraphy and all of these profiles, it has been evidenced that we're like in many cave sites, some cracks appear and some faulting took place. In some cases, there is no main impact on the infilling. That is, it's just a little crack with 10 centimeters, 15 centimeters of dip between the two compartments. These are the three little photographs on the right and on the bottom part of the cave, affecting either the ensemble 1 or mostly the ensemble 1. And on the top photograph on the left is the faulting, the evidence of the movement of the sediments in more clay sediments of the ensemble 2. Miroir de faille in French. I forgot it in English. Sorry. It's the illustration of the movements of the sediments of the two compartments. And so, next slide, please. We can see on this slide, which represents the profile between the band 20 and 21, that some in orangish and in brown are some intrusive layers. That is, when the top part of the sedimentation has been sedimented, when the top top part of the ensemble 3 has been sedimented. When the ensemble 4, when the Speleothems began to deposit, they cemented the sediments below, and so doing so, the little subsidence of the sediments, when it took place, they led to openings in the sediments, to open cracks, in fact, instead of the photographs just before. So these were open voids, cracks in the sedimentation, either between a cemented part and a non-cemented part that is going down, or between more or less cemented part that cracks, so that makes the more or less horizontal or vertical cracks that were filled much later by intrusive sediments. And these intrusive sediments, the orange and the brown one on the photographs, are called the sommital stratigraphic complex. That is so this is the fourth stratigraphic complex of Arago cave. It's not in stratigraphy, it's just intrusive sediments in much older sediments. So this was really important to recognize that. So with different methods have been applied, the classical magnetic susceptibility can be applied on profiles in order to see more the difference of sedimentation if it's unseen through the eye. So you have the evidence here at the lower part of the profile of layers with high magnetic susceptibility, with the log on the left. The next slide is also for magnetic susceptibility analysis, but through the most of the infilling, that is 8 meters of the stratigraphy, which reveals peaks in the magnetic susceptibilities that have different origins. So maybe due to burning, so maybe due to climatic conditions, bringing more clayey sediments, and so clays with more irony materials, clays with iron oxides and hydroxides. So it gives often a higher magnetic susceptibility. Or the third point is also diagenetic. So the evolution of the sediment may lead also to peaks in the magnetic susceptibility. So the interpretation of the signal is not straight. More research is always to be done to go further. So next slide, please. Of course, some of the continuity of the stratigraphy is called micromorphology. It consists of taking blocks in the sediments, undisturbed sediments, to impregnate them in resins with polyester resins. And so when it's polymerized, you can process the block as a rock, as a solid rock, and make a thin section that is red, that is studied under the petrographic microscope. And so you have an example on the right of the slide. And the next slide is an example of the results of the micromorphology. For example, ensemble 1 and ensemble 2 are represented by little 2 centimeters by 2 centimeters parts of synthections at the base of the illustration and at the top, and they represent directly wind-blown sediments. But the ensemble 2 in between is clearly something different, and it shows that the sediment is much finer, with no big layering, with no layering, but the layering has been partly disturbed by biological activity. So this is one of the information given by micromorphology in this site, the origin of the mode of deposition. Thank you. Next slide, please. The granulometry has been applied, of course. The granulometry gives you information on the different size of the elements in the composing the sediments. And when you have a Gaussian curves, of course, there's one well-sorted sediment that is that arrived at this position, and it can be either the runoff, either the directly wind-blown sediments in the cave that may have accumulated, or in orangish or grayish, reddish. The other curve represent more diverse sediments. Either it's the sample, because with laser diffraction you only need really a little quantity of sediment. Either it's your sample that is mixing different layers, either the layer itself is composed of many different granulometric, different size of grains. And so this is different interpretation that you have to couple, that you have to check with micromorphological research, for example, in the same layers. So next slide, please. Granulometry will also be represented like this, with on the left the clay fraction between ensemble 1, 2, and 3 for many samples, and the silt, it's on the middle left. The fine sands are on the middle right, and the coarse sands that are particles between 200 and micrometers and 2 millimeters are on the right part of the graphic. And you can see that ensemble 2 is really represented by a decrease in the fine sand and an increase in the continuous increase in the silt and in the clay. But the information on the coarse sand is completely blurred. It doesn't correspond to any evolution, even though in the coarse sand is much in lower quantities than in the above and lower stratigraphic complexes, ensembles. So the interpretation of that is that the sedimentation is really calm, gentle, and there is not almost no movement of objects that can be evidenced with this type of sedimentation, like displaced by a runoff or so on. It's really low-grade energy. So next slide, please. Some work has been done also on the sand fraction, with recognizing just their aspect. And so 4 main categories like this, like you can see, have been recognized. And some are more present in some of the ensembles, and some are in other. For example, the matte ones are more present in the ensemble 1 and 3, and the shiny or uneroded are more in the ensemble 2 layers with the bipyramidal. And so this gives you an idea of the origin of the grains that can be further studied with the next slide, which represents the exoscopy that can be sometimes applied. Next please. It's a continuity of the morphoscopy, like but under microscope, and sometimes you can recognize aeolian marks, but doesn't mean that this is of course the wind that brought the grain in the cave, because some of these aeolian marks may last quite long, for a long time. But for example, the dissolved surface of the elements of quartz or more fragile minerals gives a good idea of the evolution of the geochemical evolution in the site. Next slide, please. The origin of the sediments is well known in Caune de l'Arago through the heavy minerals study, because you can see on the top graph that the paroi means the wall of the caves, plateau, the different minerals, these 5 different big categories of minerals: tourmaline, epidote, zirconium, garnet, and titanium oxides. It clearly shows that the plain, the valley, is much richer in tourmaline in the upper graph, and in the lower graph you can see the amount of tourmaline, which is much more abundant in ensemble 3 and ensemble 1, the sandy and bedded sediments. And so it seems, of course, that the ensemble 1 and 3 are originating from the plain, and it fits well with these windblown sediments that have been laid in the cave. And the next slide shows an experimentation that has been made to try to understand. So the cave is on the left, and with the geometry of the valley that you have seen in the first slides, it has been evidenced that the little sun grains can be brought by the wind from the bottom of the valley. The swirls are made when the dominant wind is blowing. It is a tramontane from the northwest, and they bring the sediments, they accumulate the sediments, they sweep the sediments from the valley, and they accumulate it, in fact, in the front of the Caune de l'Arago. Then either they're brought directly in the cave, or they are laid in the cave with a storm. So this is a way to pinpoint the origin and to explain more the origin of the sediments. Next slide, please. So during the excavations, many stony objects, limestone objects, limestone clasts have been found with a cortex, and bones sometimes are weathered. And in order to understand that, some further analysis have been undertaken. It's quite classical in cave sites. Then next slide, please. So when you map the objects, when you observe the stratigraphy in the middle, and just behind, next slide please, you can see the stones. It's a bit dark, I don't know. The little red dots are the stones. You can see on the left part of the projection, it's a vertical projection of the stones that have been found in 10 centimeters, in a band of 10 centimeters, vertical 10 centimeters band, the coordinated stones, limestones. And so on the left side, you see no stones. Next slide, please. The non-determinable bone on next slide are more abundant, and the bones and teeth are more abundant, but still you have no continuation of the main concentration of the objects. And the next slide is the lithics, mostly in silicium, And so you have the continuity of the archaeological layers on the left part of the graphic, in a way, on the illustration. And this is the proof that there has been a localized weathering zone affecting the left part of this profile, for example. So the next slide is again the same profile. Sometimes we can see the next slide, please. Yes, and so you can see the continuity of the archaeological layer in this ensemble 3, which is with limestone and bones on the right, and then going to the left, the limestone are weathered, and then the white dots are the completely weathered or almost completely weathered bones. When you want to understand that, you go further with micromorphology, for example. Next slide, please. And you make thin sections in the non-weathered part. These are the 2 slides on the right. And in the weathered part, these are the 5 slides in the left part, which shows completely different microfacies, microstructures, with kind of odd elements that are reprecipitation and dissolution of iron and manganese oxyhydroxides on the upper left, translocation of clays on the lower left, phosphate precipitation on the middle part of the lower one, etc., etc. Dissolution of the limestone, etc. So you understand more the in situ weathering. Next slide, please. And so the micromorphology with quite heavy sampling can reconstruct an evolution, in fact, of the weathering from really slightly weathered sediments with just some oxyhydroxide precipitation towards a really heavily transformed sediments with no more carbonates and with phosphatization in the complete phosphatization of the sediments. Next slide, please. Try to finish. The micromorphology can be helped with quantification with geochemistry. The upper part gives you the dosing of the calcium carbonate on the profile. It has been sampled thoroughly, and you can see in the yellowish tones the lower content of calcium carbonate, which is a weathered part, and the lower graph is the same analysis, thoroughly, the same profile, thoroughly sampled, but with the illustration of the phosphate content of the sediments, which are really highly enriched in some places in what we call the phosphatic pockets. So next slide. In order to go further, we can process to X-ray diffractometry, either on a bulk sample or like what is presented here. It's on a thin section. It's just a micro diffraction, which reveals calcium phosphates. And also on the right part, you have a slide of secondary mineralization showing the same carbonate hydroxyapatite, a calcium phosphate, calcium phosphate, with the analysis in weight percent made through the microprobe. So these elements, these analysis allows to detect really evolved chalcoaluminous phosphates and they show that the evolution has been really strong, really heavy in some places, and sometimes localized, probably due to bad guano, but it's not proved yet. So, of course, these transformations have quite a great impact on the geochronological part of point of view of the site, while you're dealing with analysis uranium, thorium content of teeth, for example, and of course on the distribution of the objects, as we've seen earlier. Next slide, please. It's soon finished. This slide is to show you the stratigraphy in the ensemble 1. We were dealing with ensemble 3 just before, with the phosphatic evolution. Here in ensemble 1, we have faced these brownish, blackish layers, which were really puzzling, and they turned, in fact, to be, with the next slide illustrating the calcimetry, so it's quite the same profile, 2 meters further, the profile, showing that the parts where the sediments were the brown are highly decarbonated zones. It's on the lower part of the graph of the illustration. The smaller the little round, the smaller the amount in calcium carbonate. So you can see there is a gradient, and the lower you are, the less calcium carbonate you have. And analysis, the next slide, is an illustration of organic chemistry analysis that has been made on these layers with gas chromatography to show that the brown layers are made of organic matter, and this organic matter is from vegetal origin. So the interpretation is probably the lower part of the infilling has been weathered, but not at all like the upper part, like the ensemble 3, where there is an enrichment in phosphates. In this part, there is much less phosphates, no carbonates also, but an input of organic matter. So the next slide is, I think, the last one before concluding. We also are proceeding to petrography of the Speleothems that shows a big diversity in the type of crystallization. And this, of course, has an impact on what kind of calcite we can choose best for the geochronology. So, in conclusion, sorry for being late. The lithostratigraphy, of course, is the base of the study. It begins on the field, of course, and it establishes the succession of the different layers. But it has to, so these are the complex, the ensembles, and the intrusive layers, RFO, RFB, for example, in here, 4.1, 4.2 are the speleothems at the top of the stratigraphy. And superposed to this lithostratigraphy, I just put in red with the A, B, C until Q letters are the archaeological layers. So this will be the next talk. And of course, the lithostratigraphy has to be interpreted with care, with all these analyses that I've presented. And it is, after that, better understood. The results of the geochronology may be better understood, and this is the stratigraphic photo of the site showing the uppermost layers roughly at roughly 100,000, and the nowadays lowermost excavated layers at 560 layers. Next slide, please. This stratigraphy, when you compare it to the isotopic curve, shows that the sedimentation rates are really different between the glacial, in a way, and the antiglacial phases. And the next slide is just to show you, just the conclusion. All the methods that I've presented are evident, are of course to be are just part of the study of the site, and Anne-Marie will talk about many of the disciplines that are really important to complete the reconstruction of the history of the site on the right corner. And so this is the last slide is the biostratigraphy. I didn't speak about it, but it's one of the main information about, of course, the climate. The sediments are not giving a lot of information about the climate, just about the hydric regime in a way, and of course about the evolution. And those the main animals, and the little skulls are for the layers with human remains. And the little hand axe is like where really real hand axes have been found in the infilling, not only the layers with Acheulean like lithics. Excuse me for having been a bit late.
Thank you very much, Christian.
Yes.
So I ask